Students, coming to the continuation basics, here we are going to see some memory sizes. For example, here either logic 0 or logic 1, which is represented as a this is 1 bit, logic 0 or logic 1. For example, if it is a 4 bit, that represents 1 nibble NIBBLE, and if it is a 8 bit, 4 bits, 8 bits, 1 byte, the size of the 8 bit equal to 1 byte. So next one is 16 bits equal to 1 word. So 32 bits. Next one, this is double word. 4 bits. That is equal to odd word. Here, double in the sense of 2 into word equal to 16. So that this is represented as a double word. Here, odd into 4 into 16, that is equal to 64 bit. Next one, 1 KB is equal to 104 bits. Next to 1024 KB equal to 1 MB. Next 1024 MB equal to 1 GB. 1024 GB equal to 1 TB. 1024 TB equal to 1 TB. Like this, we are going to increasing zettabytes like this continuation. Here we are going to see 0 or 1, this is 1 bit and 1 nibble. The size here 4 bits represented as a 1 nibble. So 8 bits 1 byte, 1 word means 16 bits like this. 32 bits double word, quad word, 1 KB, 1 MB, 1 GB, 1 TB, 1 PB like this, petabyte, terabyte, gigabyte, megabyte and kilobyte like this. In this tabular form, we are going to see here name, that means kilo, mega, giga like this. Abbreviation, kilo is represented as a KB, and a size 2 power, kilobytes means 2 power 10. So number of bytes 1024 bytes. Same as it is, we are going to see on basic tabular form. This is very, very important in competitive exams. So we are going to divide it into 3 columns. That means number of address lines. Number of address lines. Here locations, that means locations, memory size. Third one, memory size. Coming to this one, the number of address lines equal to 1. Locations, we are going to consider that 2 power 1, that means 2 bytes. If word size equal to, very, very important point, word size equal to 8 bits. Suppose if you are going to consider any memory, that means memory. So if word size equal to 8, that means this tabular form will applicable. That means number of address lines 1. Here 2 power 1 equal to 2 bytes. 2 power 2, that means 2 address lines. 2 power 2, that means 4 bytes. Next one, if it is a 3, 2 power 3, 8 bytes. 4, 2 power 4, 16 bytes. 5, 2 power 5, 32 bytes. 6, 2 power 6, 64 bytes. 2 power 6, 7 continuation, 7, 128 bytes. 8, 2 power 8, that means 256 bytes. 9, 2 power 9, 512 bytes. 10 address lines, 2 power 10, that indicates 1024 bytes. So this is a very, very important point. If it is a 2 power 10, that is equal to 1024 bytes, that means 1 KB, 1 kilobyte. So first one, this one, kilobytes, KB, 2 power 10, address line 1024 bytes. Same as it is here, 11 address lines, 2 power 11, that means 1024. Next point is here, see, here every time this is a 2 is, that means double again, then 4 is double, and 8 is double, the next 16 is double, 32 is double, like this. Here 1024 is double, or 1 KB is double, that means 2K. 2K means 1024, that is equal to 2048, like this. That means 12 address lines, 2 power 12, that means 4K. 13 address lines, 2 power 13, that means 8K. 14 address lines, 2 power 14, that means 16K. Like this, we are going to see 20 address lines, 2 power 20, that is equal to 1 MB. 1 MB equal to 1024 KB. Mega MB 2 power 20. These are the locations. 2 power 20 locations. 1024 KB equal to 1 MB. That means coming to this one, 30 address lines. 2 power 30 address lines. That means 1024 MB equal to 1 GB. So this is the way we are going to see here: 2 power 10, 2 power 20, 2 power 30, 2 power 40, 2 power 50, and so on. So kilo, mega, giga, tera, peta, like this. So this is the way we are going to representing the address values and also memory sizes. In this tabular form, we are going to observe if the address lines are 4, automatically you can say that directly 8 bytes, 16 bytes of the memory we are going to access. If it is a 2 address lines, how much memory we are going to access? 4 bytes. So if it is a 10 address lines, so that 1 kilobyte memory we are going to access. Or suppose if you want to access 64 kilobytes of the memory, how many address lines are needed? That means 6 address lines are needed. Suppose if you want to access 256 kilobytes of the memory, how much address lines are needed? That means 8 address lines are needed. Like this, either address lines are used to find out the memory size, or memory size, with the help of memory size we are going to identify the number of address lines. This is the way we are going to calculating size of the memories with the help of address lines.